today's lesson will be about the modulus function. What we need to know is that every number in mathematics has a symbol and has its magnitude, has a sign and its magnitude. So 3 is the magnitude of this number, magnitude, and the plus is its sign. Okay, and if we take another number, for example, like negative 4, 4 is its magnitude, and the negative one, the negative is its sign. Okay, so what is the modulus function? It is basically takes any number, for example plus 3, and you put it through the modulus function, which is two straight lines between the number, like this. What the modulus function does is that it removes any sign and just leaves the magnitude. Let's put, for example, negative 4 in the modulus function, negative 4, you will get 4. Okay, let's, for example, do another number like negative 126, and we put it through the modulus function, we will get 126. So the basic idea is that the modulus function removes any sign and places and brings you only the magnitude of the number. Okay, let's take, for example, the modulus function of x, and it gives you that its magnitude is equal to 3. Okay, so here what could be the values of x? Here we said the modulus function only produces the magnitude without the sign, so it means that x could have been plus 3 or negative 3. Okay, so what we could say from this formula, we could say that x equal 3 or equal x negative 3. Okay, why we did that? Because we have no idea whether x is a positive number or a negative number. So if we do the modulus function for x, it will give us 3 even if it was positive 3 or it was negative 3. Okay, so how we could write the equation? We could solve for x by doing x could be equal to 3 and x could be equal to negative 3 as well. Okay, so we'll take a more complex example. Let's say we have a modulus of ax plus b equal k. Okay, so what does it mean? What does that mean? It means that ax plus b equal plus k, or ax plus b equal negative k. So let's use numbers. Okay, we want to find the value of x. We will say a was 2, b was 3, and k was 6. Okay, so we'll do the same thing. Okay, we said that 2x plus 3 could equal positive 6, or 2x plus 3 could equal negative 6. So we'll do algebra to 2x equal 3, so x equal 3 over 2, that's the first value of x, and 2x will equal negative 9, so x will equal negative 9 over 2. Okay, so here we found the value of x by doing 2x plus 3 equal plus 6 or negative 6. Okay, so that is the first method of working out the value of a modulus function, which is doing the answer, for example, 2x minus 1 equals 3, and we write it as 2x minus 1 equal 3, and then we answer for x, and we do 2x minus 1 could also equal negative 3. Okay, so we could answer this quickly. 2x equal 4, so x will equal 4 over 2, which is 2. And here we have 2x will equal negative 2, so x will equal negative 1. So now we have two values for x. But there is another way of answering modulus functions, which we will start doing it now. Okay, which is squaring both sides. Okay, which is by squaring both sides. Okay, how we will do this? Let's take the same example. 2x negative 1 equal 3. Let's say if we square 3, we will get 9. And what will happen if we square negative 3? We will also get 9. So it means that the square of 2x negative 1 squared will equal 3 squared, because it doesn't matter the. So here if we take the square of both sides, it doesn't matter what is the sign, and we will get two values. So we'll square 3 and we'll square 2x minus 1. And let's try to answer, okay? So we will do 2x minus 1. 2x minus 1 equal 9. 2x and 2x will give you 4x squared, negative 2x plus 1 equal 9. 4x squared minus 4x plus 1 equal 9, and we'll finally get 4x squared minus 4x minus 8 equal 0, and you could do 2x squared minus, you could do it x squared minus x negative 2 equal 0, and then we will just use the calculator to find the answer, which is 1 negative 2, and we will get x will equal 2 or x will equal negative 1. Okay, so let's do it with the normal way we did first. The equation was originally 2x minus 1 equals 3. Let's do 2x minus 1 could equal 3, or 2x minus 1 could equal negative 3. 2x equal 4, so x equal 2, and here 2x would equal negative 2, and x would equal negative 1. So if we compare both answers here and here and here with x equal 2 and x equal 2, we will get exactly the same answers. You could choose which method you like most, but this method you will see as it's easier, but when you get in more complex ideas, this method will be easier. Here let's use another example of the modulus function using the squaring method. So let's take for example 3x plus 4 equal x plus 5. So what we will do here, it's difficult to use the method of plus k or negative k. It will be difficult. So the easier method will be squaring both sides and making a quadratic expression. So we'll do 3x plus 4 squared equal x plus 5 squared. And we'll square both sides. You could do it automatically, or you could expand the brackets and doing 3x plus 4 equal x plus 5, and you could do it really quickly, minus x squared plus 12x plus 12x plus 16, and here x squared plus 5x plus 5x plus 25, and you will make this expression smaller, 24x plus 16, and here x squared plus 10x plus 25, and we need to place the equation on one side and equate it to 0, so it will be 8x squared plus 14x, and 16 minus 25, we will get -9. And you could use any method of quadratic equations to get the values of x, but I will just use the calculator automatically by pressing mode 5 3 and then placing 8 14 -9. But it's better to use the quadratic formula to work out the values. So we'll get the first x equal half and the second x equal -9/4. So is there is a method to check whether our answers are correct? If we want to make sure of the answer, we could take the original equation, which is modulus of 3x plus 4 equal modulus x plus 5, and place the values of x we have, x equal half and x equal -9/4. So we have x equal half and x equal -9/4. So we'll substitute our value for x here and here and see if they will equal each other. So modulus 3 plus 4 equal modulus of half plus 5. So 3 multiplied by half will equal 3/2 plus 4 equal modulus 5.5, and 3/2 is basically 1.5 plus 4 equal 5.5, which is 5.5 equal 5.5. So we made sure of the first value of x, which is x equal half. So we need to make sure of the other value, which is x equal -9/4. So we'll substitute the value of -9/4 for the value of x. So 3 -9/4 plus 4 equal modulus of -9/4 plus 5. So 3 multiplied by -9/4, we will get -6.7 plus 4 equal -9/4 plus 5 is 2.75. So 2.75 is positive, so we'll keep it the same. And here -6.75 will be -2.75, and the modulus of -2.75, we will cancel any sign, so we'll have 2.75 equal 2.75. So now we made sure of the two values of x and we made sure they are correct. And that's how we could make sure for us. Here, let's do another example of modulus function. It's x plus 3 plus. Here, let's do another example of the modulus function, which is modulus x plus 3 plus modulus x plus 5, which is equal to 10. So we need to find values for x. First step, we can't use the square method on both sides. It will be a little difficult. So what we could do, we could keep a modulus function on one side and move the other one to the other side. So we'll do x plus 3 equal 10 minus x plus 5, and then we could separate this equation so that x plus 3 would equal positive 10 negative modulus plus 5, or it could equal x plus 3 equal negative of 10 minus x plus 1. So here x plus 3 will equal 10 minus x modulus of x plus 5, and x plus 3 equal negative 10 plus x plus 5. So we could rewrite the equation as x plus 3 modulus x plus 5 minus 10. So here we have two equations, equation 2 and equation 1. So we'll take it step by step. We will start with equation 1. We want to make this, when we have a modulus function, we wanted to keep it on one side. So we will do x minus 7, we'll move the 10 to the other side, so it will be negative x plus 5, and then that is similar to 7 minus x equal negative modulus of x plus 5. The minus will cancel with the minus, so we have x plus 5 equals 7 minus x. Okay, now we will do the same step we did for the original equation with this original equation. So we will do x plus 5 could equal negative 7 minus x, or x plus 5 could equal negative 7 minus x, which is technically x plus 5 equal x minus 7. Okay, so now we have two equations and we will answer it. We'll place x on the other side, it will become 2x, and we'll on minus 5 from the 7, and it will become 2. So the first value of x we have is 1, x equal 1, and here in the second equation we might face a problem. Here we have x on the other side on both sides, so if we do minus x on both sides they will cancel, and we'll have 5 equal negative 7, which is incorrect. Okay, so we could only find the value of x equal 1 from the first equation. Now let's do with the second equation. This equation is a little bit easier to keep the modulus function on one side. So we'll do modulus x plus 5 equal x plus 3 plus 10. We'll move the 10 plus on the other side. It become modulus x plus 5 equal x plus 13. Okay, so now we'll do the same steps. X plus 5 could equal x plus 13, and we could change it directly. X plus 5 equal negative x minus 13. So here we will face the same problem we faced in the second equation. So x on both sides, so we'll have 5 equals 13, which is of course incorrect. So we'll continue with this equation. Here we'll move the x on the other side. We will have 2x plus 5 equals negative 13, and we will move the negative 5 on the other side. It will be negative 18, so x negative 18 over 2. We will have second value of x which is -9. Now we found two values for x equal 1 and x equal -9. But now we want to make sure our answers we got are correct. So we'll take the original formula in the question and we will substitute the value of x, which is 1, in the equation. So we'll do modulus of 1 plus 3 plus modulus 1 plus 5 equal 10. So modulus 4 plus modulus 6 equal 10, and positive 4, and that is 6, so it will become 10. So here we have 10 equal 10, which means the value of x equal 1 is correct. Let's try and prove the other value of x we have. Let's keep the original formula. So we'll substitute the value of x here and here as well. So it will become -9 plus 3 plus -9 plus 5 equal 10. Now we'll add them together, so it become -6, and here -4 equal 10. So modulus of -6 will be 6, and modulus of -4 will be 4, and 6 plus 4 will equal 10. So the equation is correct. So now we have got two values of x, which is x equal 1 and x equal -9. So here we will do a quick recap, which is the first method and the second method we could use to solve the equation, which is finding the value by making it positive, or negative. By finding the value by making it positive or negative, and second method is squaring both sides. Squaring both sides. So when do we use the first form and when do we use the second form? So the first form is for the equation, which is there is only one modulus function, or it's not appropriate to use second method, and we will see why as last example. And for the second method is we have when we have two modulus functions, on both sides. Let's take examples. Let's say for the first method, an equation like 4x minus 3 equals 7, or for example, let's say 1 negative 2x equal 5, or we could do like an equation. Let's take the example we already made, x plus 3 plus x plus 5 equal 10. So that is the equations that we could use with the first method. And for the second method, it's a little bit more clearer if you have equations like modulus of 3 minus 2x equal 3x, for example, or we have 2x minus 5 equal 1 minus x. And let's take a complex one. If it is multiplied, if it is a value multiplied in the modulus, we could still use the squaring of both sides method. Here, for example, half x minus 3. So all of this, we will use by finding the value plus or minus, and here we will square both sides. So let's take, for example, here we have two modulus functions and here we have two modulus functions. When do we use finding the value by making it positive or negative, or when do we use squaring both sides? So here everything outside of the outside of the two modulus functions we have a plus. So we will need to use by finding the value by making it positive or negative, and here we have it multiplied, so we'll use squaring both sides. So I'll give a couple of examples that you could solve. Let's do 3x minus 2, 3x minus 2 equal 4. You could pause the video if you want to do it. So 3x minus 2 could either equal 4 or 3x minus 2 could equal negative 4. So 3x will equal 6 and x will be 6 over 3, which is 2. So that is the first value of x, and 3x equal negative 2. So x equal negative 2 over 3. And we could verify that our values for x are correct by substituting the value of x in the original equation. So 3 to negative 2 equal 4, so that we have 6 minus 2 equal 4, so we'll have 4 modulus equal 4, which is indeed correct. So the value for x equal 2 is verified to be correct. And let's make sure for the second value, 3 negative 2 over 3 negative 2 equal 4. So we'll do 3, it will be negative 2 over 3 minus 2 equal 4. So here's the 3 will cancel the 3, so it will be negative 2 minus negative 2 equal 4, which is equal modulus of negative 4 equal 4, which is indeed correct. So we ensured that both values of x are correct. Now let's do a more complex example. Let's take, for example, that's a little hard, but we could do it. Let's say 3x minus 2 over 5 equal 4. So you could also pause the video. So we will do 3x minus 2 over 5 will equal either positive 4, which is, you could just write 4, and here 3x minus 2 over 5 will equal negative 4. Now we will just multiply 5 by the 4, so 3x minus 2 equals 20. We'll move the negative 2 to the other side, so 3x will equal 22. So x 22 over 3, we will get, it will be a fraction value, so we'll just keep it in this form. And here we have 3x minus 2 equal negative 20, 3x negative 18, and x will be negative 18 over 3, which we could simplify, which will become 6. So we have two values of x, which is x equal 22 over 3 and x equals 6. And if you want to verify your values, you could substitute the x in the original equation and you will make sure that they are equal. Okay, now let's try with the squaring both side method. Let's take, for example, 3, let's take a simple one, negative 2x equal modulus of 3x. You could pause the video as well. So it will be, we will square both sides, 3x squared, so we will have this negative 2x multiplied by 3 negative 2x equal 3x squared, which you could do it directly, which is 9x squared. We will do 9 here, multiply this by this, and this will be negative 6x, and this by this will be negative 6x as well, and negative 2 by negative 2 will be 4x squared. And we want to change the formula, so it is in the form is ax squared plus bx plus c equal 0. So what we will do here, let's clean it up a bit. 4x squared negative 12x plus 9 equal 9x squared. We will move the 4x squared on the other side and remove the whole equation to the right side. So it will be 5x squared plus 12x minus 9 equals 0. So you could use any form of the you could use the quadratic equation, or by factorizing, or the other methods of answering a quadratic equation, but I'll just use a calculator for the simplicity, but make sure to write the working out. So negative 9. So here's the first value of x. We will get 3 over 5, and here x equal negative 3. So now we have two values of x, and if you want to verify as well, we could place the values in the original equation. Okay.